This is your full guide to creating your own event on the event editor of Observ. One thing we have to make sure is ready before making our event is our chosen model repository. You can click this drop-down and select one or more models that contain the objects we want to detect. For this tutorial, I'm going to be selecting the general model, which contains most entities that a regular user may need to detect. This includes people in different positions, cars, animals, etc. When creating an event, you'll notice various cards on the left. Let's go through each of them one by one. First, we have the object card. The object card contains configurations to modify what entity we want to detect. This is the previously mentioned person and car, and we can modify this by selecting the model repository, and you'll see here that the only options for the model are the ones we specified in the event editor. This general model includes different ontologies. If we want to try catching people entering a restricted area, we can select the person ontology. Next is the attribute. This further specifies the characteristics we want from our chosen ontology. For persons, we can select a specific pose. Here you'll see different options you can select from. But since trespassing into a restricted area doesn't have to take the person's pose into consideration, we can just select the any option, which checks for any and all attributes of the person. Next, we have our trigger area. So what we have to know about trigger areas is that the ontology we pick is bounded by a bounding box that looks like this, encompassing the entire perimeter of our target object. If we want to detect someone crossing into a restricted area, then actually we only care about the object's feet touching the zone. At the same time, we want to reduce any false positives. If, for example, a person walks over here and the top of their bounding box, which is their head, overlaps with our restricted area. What we can do in this case is we can follow the sample trigger area, which covers just the bottom part of the bounding box where we can assume the feet will be. Now we click confirm and drag the card we created into the workspace. It's also possible to continue editing the card once it's already in the workspace. Next, we have the zone card. The zone is a perimeter that we can draw on our camera view, like in the upper right. This zone defines the area we're interested in watching for any overlaps with our object. Here, we can make a new zone and configure how many we want in the camera view. For example, setting this to multiple polygons means there's more than one area we want to watch in the camera view. The color selection on the right toggles the color of the zone's outline. Let's make a new zone and call it the no trespassing zone. It's best to give the zone an intuitive name in order to easily identify what it's for whenever there are multiple zones in the camera view. Now, if we want to close the zone menu and reopen it, you can find our newly created zone in the existing zones tab. Let's drag our newly created zone into our workspace. Now let's move on to our logic gates. These are operators that function as rules to apply to the objects we have in the workspace. The with logic gate checks for the presence of an object. We can also change the logic to its negation, which is without. What we can do with this is to notify us if there's a person inside the camera view by connecting our objects to the logic gate. The final step to creating our event uses a logic trigger that creates an event if our logic is true. In other words, if a camera sees that a person is present, then the system triggers an event. Or if the camera sees that there is no one in the frame, then the system triggers an event. Moving on, the overlap logic gate is exactly as its name suggests, but with some added details. It specifically checks whether a primary object has a secondary object overlapping on it. We can use our earlier example of checking whether a person enters a restricted area. Let's select our no trespassing zone as our primary object and a person as the secondary object. Now we can connect the zone and our object to the overlap logic gate. Now we're triggering an event if a person enters our predefined no trespassing zone. Just like the with logic gate, the overlap logic gate can be toggled into its negation, which is no overlap. This is useful if a staff member must be present in a zone at all times, like in a security post. The not logic gate flips the answer of our event. If our logic is true, then the not gate flips it to false, and vice versa. To understand the difference of the not gate as compared to just negating the logic gates we mentioned, let's look at a sample scenario. Let's try making an event to look for people who aren't wearing a helmet. There are two ways to do this. The first case uses the negation of overlap, while the second case uses the not logic gate to flip the entire logic. And in both cases, our primary object is the person. In the image where a person is alone, case 1 will trigger because the primary object lacks an overlapping object. The same goes for case 2. However, case 3 sees a helmet, which is a secondary object. So we don't really care about this object on its own since it's secondary. The main focus is spotting a primary object, which is a person, and checking whether or not the helmet overlaps with it. So just a hat in the frame will not trigger an event. The same goes if there's a person in the background wearing a helmet. For case 2, we've flipped the entire logic, so the only thing that's considered true is the overlap of the person and the helmet. Anything else is false. So all these 3 situations will trigger an event. The OR and AND logic gates function like the usual logic operations in computer science. Let's say we want to catch 2-wheeled vehicles on the highway. The general model currently has a bicycle and a motorcycle ontology. We can create one case that checks for the overlap of the highway and the bicycle, another case checking for the overlap of the highway and a motorcycle, and combine it with the OR logic operator to indicate that either of the two can occur in order to trigger an event. On the other hand, the AND operator simply states that both the motorcycle and the bicycle have to be in the zone in order to trigger an event. The tagging object card is useful if we want to follow an object that has already triggered an event. Going back to our persons and helmets detection, let's say that the camera view sees both an area where you need to wear a helmet and also one where you don't have to. We only have to enforce the rule if the person is within this zone. So we can make this a 2-step process. Check if someone is within this zone, then check if they're wearing a helmet or not. We can model this logic as such. Let's set up our zone and object and check if they overlap. If true, let's tag that person. Now we can do a secondary check to see if that person we tagged isn't overlapping with a helmet. If they're not wearing one, then we trigger the event. Our last logic gate is a counter. So up until now, our logic gates have been returning Boolean values. But another thing we can do with events is to check if there are too many objects in the zone. If the capacity of an elevator is 9 people, we can set up an event like so. Let's create a counting area to count people. We can connect these 2 objects to a counting logic gate which returns a number. This number must then be connected to a number trigger that can be configured by clicking the 3 dots. In this case, if the elevator's capacity is 9 people, we can trigger an event if the count exceeds 9. The counting logic gate can also be configured. A real-time count gives you an instantaneous count of how many people are in the frame, accumulation counts the objects over a period of time, and in-out counting dynamically increases and decreases the count whenever people enter or exit the frame. Up until now, we've been using triggers to set when we initiate an event notification. We can go into the specifics of each trigger by clicking the 3 dots. We've gone over the number trigger just now, so let's look at the logic trigger. The logic trigger has 3 components. The detection duration is how long we want the camera to be looking for an event. The event interval is how long the camera will not be actively detecting the event once one has been detected. While the detection threshold is the percentage of frames where the event is true for us to trigger an event. If that sounds a bit complicated, let's get an example. Let's say we have a camera system running at 10 frames per second and we want to check if a weapon is detected. Weapons are high risk, so we want the detection duration to be 2 seconds. This means that the weapon only has to be present for 2 seconds. The detection threshold means that for 2 seconds, there are 20 frames. 90% of these frames, or 18 frames, have to detect a weapon. If that's true, then we trigger an event. This number can usually be toggled lower, especially when visibility is low, such as in the evenings or when it's foggy. The event interval will be set to 60 minutes. This means that if a weapon was detected right this moment, then the system will not be looking for a weapon for the next hour. And that's how you use the event editor. Now you can save your new event and find it under the scenario list where the event is saved. You can also find your new custom event under the events list.